Today, you're going to learn about what's called L'Hospitals Rule. L'Hopital has to do with limits. So if functions f of x and g of x are both 0 at some number x equals a, then the limit as x approaches a of f of x over g of x couldn't be found by substituting a for x, because if we plugged in a for x in f and we plugged it in here for g, and it says that they're both 0 at a, then I would get 0 over 0. Now, hopefully you remember from limits in the beginning of the year that when you would evaluate a limit and get 0 over 0, what that meant was that you had to go do something else. Okay, well, L'Hopital's rule gives us a very easy method to go do something else. Okay, so 0 over 0, that's called an indeterminate form. So it's not that it's, it doesn't equal 0, it doesn't equal 1, it's indeterminate. Okay. So here's L'Hopital's rule. If you're evaluating a limit of a rational function, so a fraction, and it yields an indeterminate form, then you can find the limit by finding the derivative of the numerator and the derivative of the denominator, and then substituting the number back in. And if you substitute the number back in and you still get 0 over 0, you can actually apply L'Hopital's rule again. You can take the derivative of the numerator, the derivative of the denominator, and substitute back in again. You can keep doing that until you get a number. So what are the indeterminate forms? So the indeterminate forms are over here listed on the left. Okay, these are all the indeterminate forms, and this is when you can use L'Hopital's rule. These are determinant forms. So you would not use L'Hopital's rule for these. However, I do like this little list to give you some reminders that, infinity plus infinity is still infinity and so forth. The only indeterminate forms we're going to worry about are these two. These are the only two that are on the AP exam. Okay, none of these other ones are on the AP exam, so we don't need to worry about the rest of those. So let's have some examples. Okay, example 1. The limit as x approaches 0 of the square root of 1 plus x minus 1 all over x. So the first thing you have to determine is, does L'Hopital's rule apply? But remember that if you're just evaluating a limit, you're never going to see L'Hopital. You're just going to see this. And hopefully, you remember from the beginning of the year, the very first thing you would do is substitute 0 in for x. So we would take 0 and we would put it here and we would put it here. And let's see what we would get. We would get the square root of 1 minus 1 over 0. And that is 0 over 0. So this qualifies as an indeterminate form, and that means we can use L'Hopital's rule. Okay. And that's going to make our lives a lot easier. Before L'Hopital's rule, you would have to multiply the top and the bottom by a conjugate, see if you could get stuff to cancel. It's kind of a lot of work. Okay. So let's use L'Hopital's rule. So we're going to leave the limit part alone, and we're going to take the derivative of the top. This is not a quotient rule. You are just literally taking the derivative of the top and the derivative of the bottom. Okay, so the derivative of the top, because this would be 1 plus x to the 1/2. So the derivative would be 1/2 times 1 plus x to the negative 1/2 times the derivative of the inside, but that's just 1. And then minus the derivative of 1, which is 0, and all over the derivative of x, which is 1. Okay. So now let's see if we could put 0 back in. So we're going to take this 0, and we're going to put a 0 in right here. That's the only place that I even have an x left. Okay, 1 to any power is 1, times 1/2 is 1/2, divided by 1/2. I'm sorry, divided by 1 is 1/2. I think that is much better than having to mess around with multiplying by conjugates or some ridiculousness like that. Okay, so I'm just going to write down here, we said this, but so L'Hopital's rule does apply. Because we got 0 over 0. So then what did we do? We took derivative of top, derivative of bottom, and we substituted again. Okay, so the limit as x approaches 0 of this is 1/2. Okay, let's come down to the next problem. Oh, this one got a little more interesting. So the first thing we would always do is try to plug in the 0. And that's going to be 1 minus 1, 0 over 0. So L'Hopital's rule does apply. So we're going to take the derivative of the top. So that will be 1/2, 1 plus x, to the negative 1/2 times 1 for the derivative of the inside, minus 0, because that's the derivative of 1, and minus 1/2, because that's the derivative of x over 2. So remember that x over 2 is really like 1/2 x. And the bottom would be 2x. Okay, so now we're going to plug the 0 back in, and we're going to see what happens. So we'll get 1 plus 0 to the negative 1/2, so that's still 1 to the negative 1/2, still 1 times 1/2 is 1/2 minus 1/2 over 0. See, I got 0 over 0 again, but that's okay because I can just apply L'Hopital's rule again. So now I'm going to take the derivative of this. So the derivative of this part, so the exponent will come down in front and get multiplied by the 1/2 that's already there, times 1 plus x, subtract 1 from the exponent, so that's negative 3 over 2, times the derivative of the inside, which is 1. These are all constants, so that the derivative of that is going to be 0. And then the bottom, the derivative of 2x is 2. So I'm just going to simplify this a little bit. And now we can substitute the 0 back in. So we can put the 0 here. And we're going to get negative 1/4 times 1 to the negative 3/2 over 2. This is 1, so times negative 1/4 and divided by 2 is negative 1/8. I certainly would not have wanted to deal with this and multiplying by a conjugate. I don't even know how I would do that. That's horrible. I guess I would split it up into 3 little fractions, but this was still better. Okay, let's try some more examples. Okay, so here we have sine of x over x squared, which will give me 0 over 0, so I'm going to use L'Hopital's rule. So we're going to change this to the limit as x approaches 0. Now this is from the right. The derivative of sine x is cosine x, and the derivative of x squared is 2x. And if I put 0 over 0, if I put 0 in here, I'm going to get the cosine of 0, which is 1, over 2 times 0, which is 0. So 1 over 0 is not an indeterminate form. What that really means is that there's an asymptote there. And so if you're coming from the right, you're either approaching positive infinity or negative infinity. So we're going to have to figure out which way we're going. So let's see here. If you put in a number that's a little bit to the right of 0, so let's think. So sine of 0 is 0. And of course the bottom is going to be 0. But what's a number that's a little bit on the right side of 0? 0.1 or something. And I know you don't know what the sign of 0.1 is, but let's just remember what the sine graph looks like. The sine graph looks like this. So if you're a little bit on the right side of 0, you're positive. The bottom will always be positive because it's a number squared. So if you're on the right side of 0, this is definitely going to positive infinity. Okay, let's come over here. Same problem, but now we're coming from the left. So LHospitals Rule would apply because I would get 0 over 0. So take the limit, x goes to 0 from the left. Again, of course, I'm going to get cosine x over 2x. And when I put in 0, I'm going to get 1 over 0. But now let's think about this is sine. And if I kept going to the left, right, that would be the sine graph in the other direction. So again, the bottom will always be positive because you're squaring a number. So if you take a number that's a little bit less than 0 and plug it in the bottom, it doesn't matter. You're still going to get a positive number. It'll be a very small positive number, but it'll be positive. And then sine x, but a little bit on the left, see, that's going to be a negative number. So that's how I know that this limit is going toward negative infinity. Okay, let's look at example 5. Okay, so the first thing we would always do with any limit is try to plug the number in, because sometimes that's just the answer. Now when I plug in secant, when I plug in pi over 2 to secant, I have to think, well, that's 1 over cosine pi over 2. And cosine of pi over 2 is 0. So that's going to be a problem right off the bat. 1 for the bottom here, 1 plus the tangent of pi over 2, that's undefined. So this is immediately a problem. Okay, but as the tangent function approaches pi over 2, what it does is it goes to infinity, because the tangent function, just as a reminder, looks like this. And there's an asymptote here at pi over 2. Okay. However, how do we know that it's, coming from the left or the right? We don't know, so we're going to have to investigate that further. But in any case, I definitely have like infinity over infinity, or maybe it's negative or positive, but it's definitely infinities. Okay, and that's another indeterminate form right there. So that's the second of the two indeterminate forms that we're going to use LHospitals Rule for. Okay, so let's just look at the limit as x approaches pi over 2 from the left. We'll just start with that. So as we approach from the left, right, as we approach from the left, let me put tangent back up there. As we approach tangent from the left, we're going up. So the bottom of this fraction then is positive infinity because tangent on the bottom. Secant, I don't know if you know what secant looks like. Here's cosine. And secant looks like this. So wherever there's a 0 on cosine, there's an asymptote on the secant. And then these little red parts here, these get flipped like this. So if you were in honors pre-calc last year, you probably learned these, but if you were in my class last year, you probably didn't. So, but anyway, you can see as you approach pi over 2 from the left, it's also positive infinity. Okay. So let's take the derivative of both sides, of the top and the bottom, I mean. So the derivative of secant is secant tangent, and the derivative of 1 plus tangent is secant squared. So I can cancel one secant with 1 on the bottom. So now that's tangent over secant. But let's come down here. Tangent, let's make this tangent times 1 over secant. Tangent is sine over cosine. And 1 over secant would be cosine. So now those cancel, and I just get sine x. And if I put in pi over 2 into sine x, I get 1. And that is the limit. And if you put it in a calculator, you can see that it is 1. But, you know, the idea is you wouldn't do these with a calculator. I don't know if this is really, I mean, if your AP exam is only going to be free response questions, I kind of have a hard time thinking about how they're going to squeeze this in there. But I suppose they could if it was a, you know, if it was a function and it had a lot of parts to it. I suppose one of the questions could be a limit question. Okay, so let's see here. We can't plug infinity in, but if we put a very large number in here for x, that will, in fact, approach infinity because the ln x graph looks like this. 2 times the square root of x. I'll just write ln x over here so you know. 2 square root of x actually looks kind of similar. I mean, it's not exactly the same shape, but so that also approaches infinity. So this is one of the indeterminate forms. So we can apply LHospitals rule because you can only apply LHospitals rule if you're getting an indeterminate form. And if you're not sure, go look at that list above. Okay, so the derivative of ln x is 1 over x. And the derivative of 2 times the square root of x would be 2 times, and then this is really x to the 1/2. So that would be 1/2 x to the negative 1/2. So these would cancel, and I would get 1 over x. That's really bothering me. 1 over x divided by x to the negative 1/2, which is 1 over x divided by 1 over square root x, which is 1 over x times square root x. And that would equal 1 over the square root of x. There's a lot of algebra in there, but if you have trouble, you can always ask me, you know, when we meet. So if you were to put infinity in here, or not really put infinity in here, but just think about what happens when you put infinity in there. So 1 over the square root of x, or 1 over the square root of a super, super big number. So would still be 1 over a really, really big number. I mean, it's not quite as big as that one, but it's still really big. And if you recall from the beginning of the year, 1 over a really, really, really big number goes to 0. And there are just a few practice problems in your book that I'd like you to do. The book goes into the other indeterminate forms up here, but we don't need to know those for the exam. So there aren't too many problems for you to practice, but I did try to pick out some good ones. So try those problems tonight, and I will see you tomorrow, and I can answer questions, and then we can start reviewing for the exam.